Okay, so restarted the stream because we can't, what's that thing that we can't do? We can't go for we can't hit, if we hit 10 hours, you can't upload to YouTube. So, we're still working on this hex dumping utility, and we realized that if the user enters two identical file paths for the input and the output, that would destroy the PNG file, right? Because it would override it with text, basically. And we don't want to save text over the PNG binary. We don't want a tool that can corrupt people's assets, right? Even if the person enters the wrong parameters and uses the tool improperly, we don't want them to be able to do something destructive like that. We don't want them to be able to accidentally nuke assets. That would be kind of a bad thing, you know? So let's close this manual page here for git ops, and we'll just make a note of it in our documentation. So git ops, git ops, git ops, and git opt, git opt, git opt. Okay, you have that in our documentation. Let's go back to here, and I'm gonna try to get this. I am getting a little bit tired because I have been doing this for. I've been doing this for over 16 hours, right? Because 8 and 8 is 16, right? And both of my streams just went over 8 hours. So the two streams I've done in a row have gone over 8 hours. So I really need to try to wrap this up. And it's like, this is kind of ridiculous because it's like, yeah. Anyways, let's try to. Let's try to figure this out. So right here, we're thinking, you know, really we could just exit, but that, so, really we could just exit from here. No problems. But I think that, in this case, doing a return just makes more sense because when I use exit, I'm kind of saying it's the programmer's fault, something went horribly wrong, and we're exiting. So we're just going to bail out with the return instead, even though the end result is to exit, right? The end result is the same thing, but I want to write it like that just so that we know who's responsible for what, and the severity of what went wrong. The severity of what went wrong. Jeez. Okay, so somewhere in here we need a utility function. And I know we have, like, a section for utility functions somewhere in here, so we should try to look at what we have here already and put it in the correct section. So we have this file write section, not what we want. Okay, we have private API helper functions. That sounds about right. Unless we have a different, we have public, yeah, let's just throw in, I don't know. I'm gonna try to get. I want this working before I'm done. So I don't know what I'm gonna do. We're gonna see what happens, right? Like if I start to go like really slow, where it's like I'm not doing anything, right? I'm not doing anything productive. Then I'm going to stop. But I really do want to at least get this working, where we're not just getting this kind of stupidness. Like, I want the first, you know, it would be nice to have, like, at least one function work. Like, I've been working on this for 16 hours. It'd be nice to get one function working, right? So, we're gonna say int32, this is our strcmp. It's going to take a char pointer, And another care pointer. And also the thing is, does this need to be const care? Well, it's not going to be const care if it's that. Well, they should be const care, so let's go over here and let's just define... Let's define a CC for const care. So we'll say const care. And then let's shift this around a little bit, align that a little bit better. And that still looks like a little bit of a mess. But yeah, I have been going for a while. It is, like I said, coffee is one hell of a drug. I do it once a week, and when I do it, it keeps me up for a while. So, CC for const care. This will be a const care pointer. This will be a const care pointer. And then in this body, right, we're just going to do a simple loop through everything. So, we can do, oh, well, that's, so I am getting kind of stupid here, so let's just do, you know, str1 and str2, right? Let's just not... Okay, so now we want something like int32 len1 equals strlen. So we need to make absolutely sure that these are null terminated. So it seems that, yeah, no problem. Yeah, if it's 7:23 a.m., yeah, no problem. No problem. I mean, 16, what is it, 16 hours awake, 8 hours asleep equals 24, so I'm going for 16. I have about 6K lines of code to write in next 2 days. Jesus. Okay. I don't know. That's a lot. Especially like in 2 days, because I'm gonna tell you what, like, I don't write that much code. Like, I have a very verbose style, and even if we looked at my comments and my code, I don't write code that fast. Like, I don't write that code like that, like, crap. Like, well, I mean, like, we've been working on this for 16 hours, and we're at, like, I'm at, like, you know, it's very fluffy, right? My code is very fluffy, and I only got, like, you know, 14,000, right? So, you got it down, 1,400, quite a big difference. 1,400, right? So, like, yeah, I would, that's a lot. Yeah, that's a lot. Anyways, where the heck was I? So I kind of, like, scrolled around and I left something open, so, oh god, where are you? This is what I'm talking about. Oh, wait, oh no, there you are, you're right there. I'm gonna get rid of some of these breakpoints that are no longer relevant. Uh-huh. 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 Oh, there you are. Okay, anyway, so strlen, str1, and int32, len ot equals strlen, str2. And the first thing we know that, you know, if the lengths are not the same, then we automatically know that, that they're not the same, right? So we could do, like, an early bailout if we really wanted to. Or we could just compare them no matter what, because that's just going to add extra code, so why not just compare them anyways? So, but then again, it makes it easier if, I don't know. Let's just do, you know, if, len 001 is not equal to len 002, then, out, I32 out equals, oh no, 7. So I'm not going to worry about an exact delta. I'm just going to worry about, hey, it's 0 only when they're equal. So I know that strcmp probably has, like, some type of delta that actually makes some kind of sense. Probably like some lexicographic ordering, probably. My guess, just a guess. I could be wrong. We're not going to do that. So int32, i32 out. And the output is going to equal 0, right? So so innocent until proven guilty. So this is a concept that a lot of people don't know. In this age of Twitter and Facebook. But yeah, so this variable, innocent until proven guilty. In other words, it's the same until we decide that we found some type of difference. Okay. So right here, we're just going to say, you know, if they're the same, then the thing I hate about this is that I have to make a decision between length 1 and length 2. You can use the null terminator as a loop condition. Okay, yeah, so you could say, I can do, oh, you're right, so I can just do this. I can just go, so this is way too bulky then, right? Because we can just do, we can do while, we can do while, str, we can do while str, one dex, let's just do I, a, no, hold on, a plus plus, b plus plus, something like this, and while str and STRA and STRB. Now, yeah, STRA and STRB. Okay, dereference the string. Still needs some incrementing there, though. So where is the increment there? So A and B inside loop. Oh, okay. Inside the loop, yes. Okay. So you're, okay. So actually, that makes a little bit, yeah, so I was gonna try to do it without a loop body, but I think that makes a little bit more sense. So we could just say I, and I could start at 0, right? So I32, I equals 0, right? And then inside the loop, we can just do I plus plus, and then is, if it's all equal, is I going to be the correct length? Well, it's going to exit when I hits the null terminator, right? No, it's going to actually hit the null terminator, right? Because both of them have null terminators. If one's null terminated and the other one isn't, I'm going to assume that's just a mistake. That we're not going to hope for that. That's bad. Let's see. So let's say that let's say there's only one character in here, right? So I starts at 0, and I starts at 0, but they're both equal. So the first character is like A, right? And then I plus plus. Okay. And now I is 1, and it's a null terminator. Okay. And then we plus plus, and then, ooh, hold on. We're out of bounds of the, yeah, let's not, you know what, let's just try not to get, how about we just try not to get too clever? How about that? Maybe, if we try not to be so clever, maybe we wouldn't have any trouble and this would just be easy. So maybe we should do this. And, actually, no, hold on. Whatever, let's just write it and get it working, right? So, I'm not gonna try to be clever. I haven't had enough sleep to be clever. So, you know, if this is equal to this, then, we keep on going, and otherwise we break. Let's just write it and get it working. Okay. So, we're not gonna do anything here. Because we can use I as the length of the string, right? So, if there is only one element, then the first thing is 0, right? So, while I plus plus... Oh, actually, no. Sorry. While... after loop. With previous logic. Okay, hold on. So, stri minus str... stri minus str1i minus str2i after loop with previous logic. Okay, hold on. Oh yeah, but no, they're different. If they're different, we have something that doesn't match, and yeah, I'm making this too hard. Okay, so, okay, you know what? This is called. So, I'm gonna do this thing called not being a tryhard, I guess. But actually, I do like a while loop. So, I really do like a while loop, though. So, yeah, this is me. I need more sleep, and also, so I do like the idea of not arbitrarily choosing one of these or one of these. So I do like that because I like symmetry in my code. Is there a difference if both of them are positive versus if they're both zeros? If they're both zeros, a multiplication by 0 gets, you know, multiplication by 0 gets you a 0. So, crappy crap. If any one of them is an old terminator, right, we get a 0 when we multiply it together. And can we use that for any type of, I don't know. How about while len 0, 0, you can return len 1 minus len 2 to be the same as strcmp. Okay. And now that, oh, got ya. So we return the lengths. If we want, like, the, okay, got ya. So you're saying right over here, right? This output here, you're saying we can do, len, right? If the first is higher than this, if the first is higher, it turns, okay, got ya. So you can do this here, right? Right, so that we can use this as a sorting. So we could plug this into a sorting algorithm and get correct sorting, right? Oh, you said len 1 minus len 2? So, sorry. So I'm used to taking, you know, higher minus lower in math. Not like that. Like in here. Yeah, let's put that back. Okay, I'm just gonna get this working, because I don't know what I'm doing. So while I... Right? While that... And, I don't know, man. And, I don't know what I'm doing. How about that? And... I know. Oh, you know what? I'm not thinking here. No, it's because I wanted to exit, right? Whatever. I don't want to take the number of characters. What am I doing here? I was backtracking, but yeah, it's len 1 minus len 2. Any char is higher than the null terminator 0, right? Yeah, got it. Any char, yeah, because any yeah, because ASCII characters, got it. So. Let's see, this equals that, and that equals that, and... no, that's not good. Okay. Whatever, you know what, num matches plus, whatever. Int 32 num matches equals 0. So this is the str len, right? So this is, the equality is always true because you are in the else body. In the else body. Oh, crap. Len, oh god, the lengths are always equal. Yeah, the lengths are always equal, yeah. The lengths are always equal. And am I doing something with the length here? Oh, crap. Oh, no wonder you don't know what I'm doing, because I don't know what I'm doing. So, if we take string... If we take this string and it's a null terminator, or this string is a null terminator, then if we multiply them together, we get 0. And if they're 0... then we're going to stop the loop, right? So not equal to 0, right? And then, yeah, okay. And then here, we're just going to compare them and say, you know, they got to be equal. So if they're equal, but also if they are equal and they're not a null terminator, because we don't count the null terminator, and we might just want to call it str len, or do we want to call it? No, let's call it num matches. That makes more senses. And then, you know, if num matches, I'm gonna write it like this anyways, because I hate asymmetry in code. And bam, they're the same. Because we know these lengths are equal, right? These lengths are both equal here. And I get that they're equal, right? Because they're not equal here, so they're both equal here. So this is kind of a pointless kind of thing here. But it's just that I hate the asymmetry in code. So yeah, yes. I know. Same. I hate arbitrary choices. So, we'll justify ourselves that I'm doing this weird, because I don't know. I don't want to destroy the symmetry. And yes, it's not the best choice. It just makes things kind of awkward, but yeah. So yeah, so at this time, I get that I'm doing stuff kind of weird here. We forgot the case. Oh crap, we forgot all the case. We did all that stuff and then I forgot the case. Damn it. I'm like, okay. Good call. So, how hard is that going to be? Oh, well, STR, this and that, right? We can just do... The null terminator is good there, and we can just do a U case, right? We can do... It was 2 upper, right? So we can just say 2 upper. 2 upper, this string, equals... 2 upper this string. Alright, so while, and let's kind of format this a little bit differently, because now it's just kind of not, it's like, let's kind of I want these 2 conditions to be like, hey, here we are. Okay. So, while these 2 things are equal to each other, and when we take these 2 and multiply them together, we don't get 0, right? So, not on a null terminator. Okay. Case insensitive care compare. So that is ugly, for sure. I know there's probably... I need to go, like, read the C programming language book again, because I got plenty of very concise ways to do things, and this is a mess. But yeah, I mean... That'll probably work, I think. Unless we miss something. Number of matches here. So if this is equal, right, the number of matches equals the length of the string, then it's equal, right? And so this I32 out would still be equal to 0. We could still just set it to 0 for readability, right? And then I32 out here could be 1, right? I don't really care about the being able to lexicographically sort or whatever, because we have a very specific use case, and that's kind of the point of making it a private utility function in here, and it's not meant to be used by anyone else, because it's private, so use it at your own risk, right? So I make no warranties. I can write it in a completely stupid way, as long as it works for my needs. I think the first STR ICMP of anyone would look like that. It's okay. Yeah. So, yeah, we're just going to go out here, and we're going to return that, right? So, return I32 out. And, yeah, good enough for me. Now, we also need... What do we need? We're missing something. I feel like we're missing something. Did we make sure that we... undeft this at the end of the section? Do we have, like, the 5 in the checksum, or is that wrong? Nope, we don't have 5 in the checksum anymore. So we gotta take this, go back down to the end of here, because we added CC for const care. Alright, go take this, we're just gonna paste this, we're gonna undef this, then we're going to... Okay. And what else do we have to do? So we have it right here. And strcmp. So if it equals 0, they match, blah, blah, blah. Okay, let's just try to get this working. Let's get it working. No, we actually have to compile. So, where are you? Compile. To upper, so we got to include upper. So, include upper is in C type, so let's go to this file here, and just include it, oh, not here, in the, yeah, in here. It's just a mess, that's all. So we'll include it in here, and say, you know, include C type dot H, and to upper and to lower, right? To upper, to lower? Yeah. To upper, to lower, okay. And I, undeclared, because we were all over the place and we didn't know what we were doing, and we just kind of hacked it together. We lost track of the variables we were using. We don't even increment I. It's like, what the heck? It's like, I'm sure that there's some relationship where number of matches in I could be the same variable, but I just want to get this working, so we're just gonna call it I for now, and or we can just call it dex or idx, but I want to keep things consistent with the way I do them, so we're just gonna call it dex, and the first index, and then we plus it, right? We're gonna plus it. Oh yeah, number matches, right? Yeah? I think we can do that. Right, so the number of matches is... too big of a name? Yes, M. We can use M. M. Number of matches. Let's just use M. And then... Okay. And then, alright, here, M for number of matches. Let's make sure it's declared in the same scope. Yes. Okay. And then we can stop this nonsense here. We can kind of make that shorter again. And we could really actually make this shorter as well. We could probably just get rid of, we almost have a... Okay, you know what? So let's kind of fix this. So let's do... This is S1. This is S2. Right? And this is S2 here. Okay. And if we do that, then, now, does everything kind of fit nicely, or do we have to... So while, this is a function right here, our to upper... not a null terminator, so we can... Okay, and then we could probably put the and right there. And then we could actually flip this one over here if we wanted to. We could put this over here like this. Bam. We could put this and over here like that. Not quite. You know what I say? I say... I'm gonna say, just make a macro for to upper really quick. Okay, cool. Then right here, and then we can kind of This is surrounded. This is for this. So can we kind of get that to look kind of nice? Right, so times. So instead of equal, it's times. And then just gonna do this. And then, if we wanted to, we could put the M++. I do kind of like having a little bit of space for the M++. Like that, right? A little bit of visual padding in between. And what else? I think... So... Yeah, so I am not gonna be able to understand this if I look at it in a while, so I should probably... This is terse, but, if neither is a null terminator, and so if neither is a null terminator and both values are equal, then M++. Alright, so we can make a little note of what's going on here, because this is kind of too terse for me. But right, so we can make a little note about what that is. Oh god. Okay. So let's add a little visual space here. And M is number of matches. We don't need this comment right here. Because we see M++ and we see number of matches. We got this little block comment here. So there we go. Stack Overflow. I'm going to check that out. Oh, nice. Okay, cool. So it's Stack Overflow. So S1. Okay, so dereference S1. And dereference S1 and S2. Okay, and so we're doing pointer arithmetic on it, right? Okay. So just get the next address, and then dereference. And so this S1 here is arbitrary, right? It could be S1 or it could be S2, right? And when we dereference it, we just don't want the we just don't want it to be a null terminator, but the thing is that if it's a null terminator, if at least one of the... So it could be... This could not be a null terminator, but it'll still stop on a null terminator because... this thing here, right? Because, if this is 0 equals 0, right? Well, then they're both a null terminator, therefore it's going to stop here. Got it? And that's why you only need one check for a null terminator. Okay, that makes sense. So that would be the most terse, proper way to do that. Okay, got it. So let me see if I can remember that off the top of my head. So that algorithm, let's just get rid of this. So the loop here is going to be while, and we're going to take the address of the string, right? So we're going to say we're going to just dereference S1. And we're going to say that when we dereference an S1, right, so if we dereference these, right, and if that's the case, then M++, right, M++, got it. And then, like, I would probably, that's nice, I would probably do... I don't know, I guess it's nice, maybe we should just do that, keep it like that. Because I would probably do, like, you know... No, I like that, because then we just... Oh, I'm missing something, hold on, my bad. So not quite yet. because we actually have to increment that. So, we do S1 plus plus, you know, S2 plus plus, like that. We could do this. M, and yeah, okay. And let's look at the code for a second, see if that's correct. S1 plus plus, S2 plus plus, and oh, while return. Oh, I see. So, the failure, so we're saying that the failure condition, if the failure condition is that there's a null terminator, then they're both equal. The thing is then, okay, I see what's going on here. So, right, yeah, okay, I get it. So, the failure, right, we keep on incrementing this, and because the failure condition is the null terminator, and now the failure condition on the null terminator could be because one of them is null, or it could be because both of them are null, right? It could be either of those conditions could cause the loop to fail, and that is why we can subtract them right here, right? Okay, that makes sense. Okay, I get that. So how about we do this thing? So in art school, we call this killing our baby. So you do this. Now, actually, we need the unsigned comparison, though, don't we? Well, okay, you know what? Let's just do this. Let's nuke this for a second. Let's nuke this and start over. And let's just take this and write it, and then modify it to be unsigned comparison, right? So, S1 and S2. And then here we're gonna say, you know, S1 plus plus, my bad, S2 plus plus, and we don't need to take any character counts. I don't know, I keep on doing that, but I don't need to. It's not a str length, it's just a compare. And then we're going to return. We're going to return this, so, okay, so we have this while. And this works because the pointer, just because we're messing with the pointer, well, pointers are still passed by value, so that's okay. That's why we can add to the pointer without having any bad effects, even though I kind of forget about that sometimes. And if that happens, then all we gotta do, yeah, we gotta return. Now, why do we have this const unsigned char, const char, got ya. So we're doing a, because we have to, if we want to subtract, why is this that way? So this is a little bit, that's a little bit much for me. So, why the heck? Const unsigned char. Why did we need a dereference now? Because it takes an int. Right, so const unsigned char is an int. Which is a weird way to cast. Sure. Okay, so we're taking this, and we're gonna say const unsigned char pointer. Okay, const unsigned char pointer, and S1, and then minus dereference const unsigned char pointer, and S2. Okay, let me think about this for a second. So we're doing a cast. We're doing a cast to... We're, unsigned. Why is it unsigned but it says it returns an int? That's kind of weird. I don't get that. I do not quite get that. So let me move this over here. Yeah. The unique cast is quite pedantic indeed. Yeah, the unsigned cast is quite pedantic indeed, yeah. That is kind of weird. Like, I don't quite get it, but, let's just define... Hold on. So, const... do we want to just say, okay. Yeah, that is weird. So let me think about this. Const unsigned. Why the heck are we going from signed... It's unsigned. This is signed, but then this is unsigned. That's the thing that's weirding me out here. So I assume that I think the key piece of information I must be missing here is... So we casted this, then we dereference it. So we're doing we're subtracting these as unsigned values for whatever reason. Possibly because if both characters were negative, I'm gonna guess. Oh, you know what? It's because if both characters were negative, I'm gonna guess it has something to do with the ordering when both characters are negative or something, versus when both characters are positive and kind of getting some type of order that's desirable. I don't quite understand it, but I'm gonna guess that it has something to do with that. And are we missing a dereference? We got 1, 2, 3, 4 dereferences here. Or sorry, no, we have 2 casts and then we have 2 dereferences. That is kind of hard to look at. Okay, and what am I missing? I feel like I'm missing something. Yes, the unsigned comparison. So this thing here, or instead of a dereference, we want to change this up a bit. We want to say, instead of dereference, it's going to be, we still want to, well, we can still dereference it like that. That's fine. Well, hold on. Oh, no, because if we dereference it... Okay, so we could do that. So 2 upper, right? We could do that. We could do 2 upper, like that. So we dereference it to get its value. And then we have a TU command still. So TU for 2 upper. And then a TU for 2 upper over here, right? We can still kind of do this nonsense. And I'd say that that does not read very well. Like, I hate, like, using dereferences all over the place. Weird stuff like that. It's mostly because the last bit of care being undeterminate again. Okay, got ya. So let's just put that in there. We will leave out the other stuff. Let's I'm only going to incriminate myself, not other people here. Yeah, so that is just what the hell. What the hell, man. So, blah, blah, blah. And... so might want to make a timestamp of this. At vid IID. And the time, let me close some of my bash. I got bash scripts that kind of pop up every once in a while. The video ID is 0122, and the time is 0 hours, 49 minutes, and 47 seconds. Okay, and so if we want an explanation of what happened, we can check that timestamp. Scroll around, figure it out. Okay, is there anything else that I'm doing completely stupid here, or is this all I need to do? We add them to advance it. Yeah, I mean, I think that's it. I think that's all we need to do. It's just that we have to make this, you know, 2 upper. With this smaller code, it's easier to catch that subtraction needs 2 upper 2 if you want the correct return. Really, the, ooh, the subtraction needs 2 upper, yeah. Yeah, if we want the, I got ya, I see what you're saying. So now, where the heck are we gonna do that? Because we got this S1 and then we have the D reference. Let's, here, I'm just gonna do this. U1 equals, 2 upper, S1, and then U2, right, so upper, 2 upper, S2. So S1 and S2, and then we're just gonna put the U in here, and then that U1 U2 thing will just be we can just declare it here. So let's do it's still a const char, still a const char, so we can do const char, and it's not a const char pointer though, right? It's just a, oh, hold on. No, that should be right, because it's const char. It's from a const char. It's an array of const chars, so therefore it's a const char. Once we dereference this once, right? But hold on. If we do 2 upper, then we need like an actual value. We don't need the array. We need the actual value here. So we need to dereference that. And now you get U1 and U2. Okay. So yeah, so I see what you're talking about, smaller code size, being able to see things. I definitely get that, because sometimes I go through my code, and I see a lot of comments, and I'm like, I can't find my way around this code, so I start, like, stripping out comments and, like, offboarding them to, like, documentation files, because it just gets, like, really cluttered, and I can't tell what's going on. So I totally get that. That's totally true. Okay. So yeah, okay, so we got this thing here, and I don't know, let's just try to give it a run and see what's going on. And once again, let's kind of consolidate these tabs here. I probably made some type of typo somewhere, but cast to pointer from integer of different size. Cast to integer of pointer of different size. Okay. So let's look at that for a second. Did I do something? Was that me? Let's move this over to the other side for a second. Cast to integer from cast to pointer from integer of different size. Boy. So U1, oh, hold on. Oh, my bad. We can't do that because, okay, I see. So, let's do this here. Let's do the 2 upper, right? So let's grab this. Let's grab these, right? So let's do the 2 upper. Come in. Yeah, let's do the 2 upper. I see what I'm doing. And after we get the upper, right? So we have the dereference. But it doesn't look like but this is not that string was not dereferenced though. Right, we dereferenced it over here. We casted it, then we dereferenced it. So, I'm gonna take a guess and say, why not just... Yeah, that's what I'm thinking. Yeah, like, why not just Right? And then, right? Right, because that's, yeah, they're not pointers anymore. So, right, because this is not a, we dereference this, it's not a pointer anymore, because 2 upper works on an integer. And, oh, this is not a pointer, hold on, my bad, yeah, they're not a pointer, okay, I see what you're talking about. Yeah, because we're dereferencing this, it's an integer, 2 upper works on an integer, it's the actual character value now, because it's an integer. Then we have this cast here, and then we subtract the integers after we cast them to this unsigned type, and you're saying that the unsigned type has a lot to do with the fact that that last bit is indeterminate, or you could say undefined behavior, whatever you want to call it. We can't trust that last bit, so this has something to do with that. And also, maybe we should add something called semicolons, if we really know what we're doing. And... okay. Alright. Let's give that a shot. And then... okay, so that compiled, so that's good. The next thing is, I believe we didn't corrupt this file anymore. I think it's still good because we exited on that assert failure. Nice, so that's still there. Okay, so now the next thing is, yeah, first try after many tries. Yeah, so let's try to just give this a shot and see .exe, and we're gonna say PNG to naked, right? PNG to naked, and we're gonna do logo.png, right? Okay, so we still get only one of those, but did we not corrupt the file this time? Did we at least not corrupt the file, right? So let's go look at this and say, hey, do we at least still have our file? And the answer is no. Is the answer no? Okay, the answer might be no, but the answer may also be that my Windows slideshow just sucks. Yes, yes. So the answer is not I have corrupted the file. The answer is my Windows slideshow sucks. It could also be no, we did a fclose, so I don't think it's a file handle aspect that made that hard to load. But I don't know why that happened. So this is the PNG magic number. So that's good. So we got one thing. Now the question is, where are we going wrong? And oh god, just... so there could be a lot of things. It could be that we could be getting the data and just not printing it out correctly. Right, that could be a mistake. Maybe we have the number of... okay, well this is actually exactly 1. Okay, that can't be that's not coincidental, right? So it is exactly 1, right? It's not like, you know, it's not like this, it's not like 1 extra. It's exactly 1. That is very suspect. So I think that it has... so we gotta re-look at our serialization algorithm and see what the heck I did wrong. So the first thing I'm gonna do is, let's just do PNG file C2, did I call it, naked text? I don't even know what I called it. I think I call it naked text, no? PNG file C2, something, match all word only. Oh, that's a problem. PNG file... no? Or is it file PNG... oh boy, just... am I in the wrong editor? Okay, so let's look at this. Make hex string. So this thing here, is probably doing something. It's probably this utility function here. Max index is the array length. So somehow this utility here works the first time. This function right here, make hex string. It works the first time, and then it just bails on me. So if it just works the first time, then bails somewhere. So all this nonsense is working, right? Because we get that text. Here we have if the U08 dex is less than the max index, then naked text, naked dex, a new line, right? We got a new line, and we do have. Well, I don't know if we have a new line or not, but so I don't even know if we're getting to here or not. Well, we have to be. There's nothing else that's gonna break us out unless, yeah, because we're doing this. We're doing this, so we're getting this. So now the question is, we go back up to the top, and no dice. Or are we not incrementing? I don't know. Max index. U08 dex. Where is this being set? It's set right there, 0. This works on the first one. Oh, hold on. Oh, got ya, yeah. This doesn't work on the first one, therefore no comma. Which we don't have a comma, that's fine. Array length. How big is array length? Are we screwing that up somehow? Oh, hold on. Array length. This array length is the U08 array length. Okay. Okay. Okay, well that's what I say it is, but where do we actually do that? So the array is right there. So is there the possibility that it's getting a bad array length? But if it was getting a bad array length, why would it be getting... It's just weird that array length would be like exactly... Okay, you know what? Printf. I think it's the ++ in the for loop. Skipping a position. Yeah, so let's look at that. So in our for loop, and to calloc we get a oh, Gaia. So that's Gaia. So we got a gap. We have a gap in the right. We calloced everything, and we have a gap, and so we have all these literals, right? But then we have a gap between them, and so we're getting yeah, got ya. I understand what you're talking about. Okay, that makes sense, right? So that's what I was saying. Like, are we printing all of the data? Is the data all there, but we're just not printing all of it, right? So you're saying that we're not printing all the data, that there's probably more data here, but we're not printing it, but we have a null terminator. from the increment here. So this U8 dex, do you want to move the plus plus? What do we want to do here? The U8 dex equals this last dex, and so that last index, oh, got it. So this is, I see. So we're priming for the next loop in 2 places. Oh, actually, no, not the naked dex. Wait, hold on. Something somewhere is, well, it's the naked text, which is the output, right? So, naked dex plus plus. Oh, it may only be doing that on the first one, right? So, right, so naked dex plus plus. That's fine, because this is negative. Okay, so the first use value is 0, right? So then we go over here. This is going to execute because we start at 0, right? So, hey, add that comma. Okay, the naked dex is now at a free spot. Naked dex is now at a free spot. It's at a free spot. And then we do plus all of this. Okay, and so if we add this and we add 10, we are still on a free spot, right? Because we say free spot plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, we're still on a free spot. We are on a free spot right now. If we're less than the max index, then on that free spot we want to enter this value. Okay, so we enter that in the free spot. And then we increment. So now we're still on a free spot. So we're on a free spot right now. But then right here, we're on a free spot, but we just incremented again. Okay, got it. So we were on a free spot, and then we just incremented again. That's a problem. Because we were already on a free spot. We're already on a free spot. But that makes me question, well, if that's the case, okay. But that makes the question, well, if it's less than... Okay, yeah, so this thing... See... Okay. So, I don't know if that's going to fix it exactly, because now I'm a little bit confused about, well, if it's the last index, well, you know, if it's the last index, right, if it's less than max index, then, okay, you'd mean the first one? Okay. So, if this is the first use value, then all we have to do here is we have to say, instead of this being initialized to 1, we can initialize this to 0, right? So let's try that. And... okay, and then let's try this thing. Okay, alright. Yeah, so I think we got something here. Now, to verify that that's correct, good luck for me, I don't know. Well, actually, we can do an XXD, right? So we can do, we can just kind of compare, right? So we could do XXD-C 8, and then we can do -G 1, and then we can do logo .png. Actually, hold on. Before we do that, before we do that, yeah, with your help, because I kind of saw it, but then, yeah, okay, so let's take that for a second, though. Yeah, let's take that, and let's just throw that in here really quick. And then let's go XXD on here. Oh god, oh god, oh god, I don't, oh god, did I paste that? Oh god, what did I do? Oh god, Control C, Control C. So, xxd-c8-g1 logo dot png. Actually, we're gonna group, well, let's just do this first and then kind of fix it as we go. So, our grouping needs to be 8, right? I think 8. So let's try this again. So, so I think we need xxd-c, and we need one column. We're just going to invert this. One column, and the group is going to be 8 bytes. And it's going to be logo.png, right? Or actually, no, 2 columns. 2 columns, and the grouping is 4 bytes. Or actually, one let's keep it as similar to the actual stuff, right? So, never mind. So, we want to be able to compare it. So, let's, go logo.png. Okay. So now, let's take all this nonsense, and, oh, actually, we can do this. We can do, actually, this isn't quite what I wanted, is it? It's like one strip, isn't it? Okay, hold on. So, I obviously don't know how to do this. Let's, what if we did 4 and 4? I don't know how to do this. So, columns. If we have 4 columns, where... Let's just try 4 columns and see what happens. I don't know. 4 columns. 1, 2, 3, and 4. That's actually what I wanted. Now, what is that? So 4 columns, and the grouping is 4. Okay, so the column is composed of 4 bytes? I don't know, but I guess, I mean, I got the... Oh, you know what? The columns are not groups. The columns are not groups. This is a column. This is a this is a column. This is a column. This is a column, and this is a column. And the groups are really how many things to split it into. Okay, I get it. Okay, cool. So if that's the case, we have this 0, 0, 426 0 82 0, 0. That actually looks like a perfect match. Or well, I mean, the first one matches, the last one matches. I'd say this is case closed on this. Oh god, not open. What the? Oh god, oh god, oh god, oh god. Just what? Why? Why would you let me do that? Why did you let me try to open? Copy. Okay, so now we're gonna go here. We're gonna paste this, or try to paste it. We're gonna copy this again. We're gonna paste this down here because obviously our column select is being stupid. Okay, so we'll cut and paste that, then we'll go over here, we'll paste that, and first thing I notice is that same amount of numbers, that's good. Okay, and let's do a 0x, 0x, and now let's just, I'm pretty satisfied with that, right? Nice, and there's not too much, like, zero fill in here, right? So there's not anything that needs to be run line encoded like I saw in some of the other data I was working with. Yeah, I would say this is... I'd say that, yeah, there you go, right? And, it's better than the PHEXDUM. So, right, because the PHEXDUM has, like, a lot of stuff that I just don't want. So, yeah, this thing here, right, so all we gotta do is, we can, you know, we could save this to a file, and then we could include it and just... include it, right? So we could, you know, just be like, U32, my data, whatever the fuck. Some number here, right? We have to figure that part out, right? So, but this, yeah, I'm done for now though, because it's like, yeah, that's just the one part I wanted to get verified, just to be like, so I have something to show for today, because geez, that's like. Why? But okay, and that's not too bad, because that's like, what? It's like 200 lines of code, right? And they're really short lines, so, like, if you broke this up, you could, like, get this pretty compact. Like, you could, we could break this up, like, once we get, like, some formatting hacks in here, right? And kind of split this at, like, 100 about, and just paste this in here. we could actually get something that really doesn't take up too much room. Now, it could be one of these things where it's big enough to where maybe we want it to have its like own file, like it's an include file, right? Or yeah, so yeah, just keep it as an include file. That's great. So excellent, excellent, excellent. Thank you. So let's take a look at your stuff really quick before we go and see if I understand what the hell is going on. So avoid PHEXDUM. Okay, 8 bits pointer, UO8, size T, data length, char pointer is out, so output parameter, size T pointer, the output length, right? So output parameters, same way as I'm doing it. Okay, so we got size T literal count, data length divided by 4, okay, modulus 4, okay, last bytes is data length, modulus 4, okay. That's a way to do it. So instead of doing multiplication, we use modulo. Got it. And length. So the length is the literal counts times the characters per line, which is, where is that? That's up here somewhere. Characters per line. So we've kind of like made a little diagram of the amount of spaces we want, and oh, we want a comma, we want a new line. Okay, so I'll just accept that diagram makes sense. So the amount of literals times how many, when we serialize this literal, how many characters is it, right? And that's going to give us the total length of the file. And if last byte's length plus equals, okay, hold on. What is this? Are we in a loop? It looks kind of like a loop. This is some type of guard condition, I'm guessing. Last by if there is leftover bytes, right? Okay, if there's leftover bytes, then add 1 extra. Okay, I get it. Okay, I got it. And I see that it looks like you are have a slight. Maybe I'm just making accusations here, but I think you have a slight fetish for branchless programming. You know, I could be wrong here. I could be wrong, but I'm just noticing that you executed all this stuff without branches. So, well, I mean, I guess this is technically a branch, I guess, but it's not very branchy yet. Like, I see this all very linear, no indentation needed, just clustering everything together. Char pointer, hex, malloc, size of character times the length, okay? And I tend to, got ya. Yeah, so What is Creel did a video on branchless programming a while ago. Or is it, it's not What is Creel, it's like, What is a Creel? What is a Creel? Hold on, I'm gonna find it for a second. It was, Creel YouTube, let's go. So, I don't know where his video is, but he definitely does do, like, a video on branchless programming. Okay, malloc, the size of the character times the length, and the length is just the total number of characters. Okay. And char pointer hex. So mallocing this is our hex here, and in this case is giant hexadecimal string literal array thingy-mabobber. Assert hex. So we're just going to assert that it's a non-null pointer, right? So just a quick assert to make sure that this malloc actually makes sense. And the only case where that wouldn't make sense is if the length was the length is 0, right? So, or actually negative could probably do something weird, but right, we're just going to check the result of this rather than individually check other parameters. So I see what that's about. Okay. Okay, we're dereferencing out and assigning it equal to hex, so output parameters, yeah, okay. And we're dereferencing out length and then assigning it to length. Got it. So I do this at the end of the... I have a big project that practiced branchless code. Oh, cool. Okay, so I see this. This is what I would do at the end of the file, right? Because it's an output parameter, so I think, well, it's an output parameter, therefore it's like a return value, therefore put it at the end. But that's fine. It doesn't really matter, now that I think of it. So, do it there. Order doesn't really matter for that. Okay, so we're going to go through the number of literals. So, literals count data length divided by 4. And now do we actually add this to, don't we increment this one if it's not literals count? This gets truncated. Last, but oh, I see. You're gonna do something with. Okay, I think. I do that too, so I will fuck with hex. So, I had to save them there. Okay, so I see. Oh, okay, got ya. So, I see that. Oh, you're gonna do some pointer arithmetic or something. Okay. Anyways, literals count and last bytes. It looks like you're going to use literal count in conjunction with last bytes. So, instead of trying to just increment this, you're just going to keep track of the last bytes. So, okay. I think that, okay, got it. Okay. So we're going to go through the literals count here. And if I, so once again, you told me, you know, we can catch the first one, because the first one is 0. So the first one is not going to get a comma, right? Because you covered that with me. Last bytes are handles in second loop. Okay, so you got 2 loops, got it. So the hex... Oh, yeah, so I see why you're doing this. Because you're doing fancy pointer arithmetic. Got it. So, now... Okay, so... The way this must bind, just because of the way we're doing this... Like, I'm not too good at the, I could collapse the redundancy, but I was too tired to think. Yeah, that makes sense, yeah. Okay, so... Plus plus happens first before the dereference, just because otherwise this code wouldn't make sense. So it's not like I know my order of operations good enough to know that, how tightly something binds. But obviously from the code, that's the way it binds. Add a space, add a 0x. And this space in 0x is as described in the diagram. So you got the space and the 0x. We see like 1, 2, 3, that looks like 3 spaces. Let's not worry about that. As long as you have enough memory for what you're doing, it doesn't matter. Okay, so J, bytes per literal. Okay, and we're going to construct the... Okay, so bytes per literal, is that just the core of it? Yeah, bytes per literal, it's just the core of it. Got it. So a literal requires 4 bytes. Okay, got it. So we're going to eat up 4 bytes, and we're going to do that sprintf in a single function. Yes, but it's still an older pointer. Okay, we're going to do that sprintf in a single function, but in a loop. So right, so I had this massively unrolled, but you're going to use a combination of sprintf, and you're going to collect. Right, so this is my, like, 2, 4, 6, 8, whatever the heck, right here. And, sprintf, we got hex, we got, this is, capital, this is capital hex, not to be mistaken with, like, a 0x whatever, and we're only going to take, two-digit places. Alright, 2-digit places, because 1 byte is 2 hex characters, got it. This data, where are you? Where do you... This, data is actually the input. Okay, so we're going through the actual input data. And, oh, I see. Okay, got ya. So data right here, and that is why... No, that's hex and length, so that doesn't matter. Data, right, data, it's a pointer, but that still doesn't change the fact that it's passed in by value, right? Everything's passed by value. Got it. So we can do this if we wanna seek through the data, we can do this. We don't have to use the index accessor. Okay. And hex plus equals 2. And hex is a string, right? Hex is char pointer hex, malloc hex. So hex is the output, is the big output block of stuff. So sprint F. Okay, I see how this works. So the thing that kind of confused me is that right, this address, this is a different address each time, right? So we're changing where we're seeking in hex. Okay, so I kind of get how you can think of hex like an out iterator. Yeah, okay. So yeah, I see how we're manipulating. That's the part that confused me when you're like, you can just use sprint F for everything. I'm like, I don't get it. And now I see kind of how you're doing it, because you're kind of moving this along like that. So okay, I get that. So bytes per literal, or there's 4 of them. 2, 4, 6, 8. Right? And that's 1, 2, 3, 4, 2, 4, 6, 8. Yeah, right? Yeah, 2, 4, 6, 8. That makes sense. That math adds up. Okay, so after we've aggregated all of the digit parts, we're going to fill the rest of the diagram. So this part right here is from this side over here, this side of the diagram. And then down here, we're going to do the... So this is going through everything. So literals count, yes. So literals count, and this is the leftovers. Literals count. So same deal, like a copy-paste, right? Copy-paste, so just copy-paste from up here. Copy-paste, got it. And so basically same exact thing it looks like, except with the last bytes, right? Sprintf hex, yep, okay. Bytes per literal, minus, okay, so this looks a little bit different. So this is the extra little thingy that looks a little bit different, like, because looks the same as the other thing, just with last bytes. Yeah, this is hex, bytes per literal. Hex, bytes per literal. Okay, so this thing is what I need to figure out now. J less than bytes than literal, minus last bytes. Okay, so basically, we're looking at the delta, just to say, like, is there anything left, right? Yeah, because the last bytes is going to be something that does not modulo evenly into this, right? So, well, hold on. Last bytes, well, if last bytes is 0, what happens here? J equals 0, J is less than bytes per literal minus last bytes. Hold on. To finish the unfinished, yeah, yep, I get that part, yep. I get the high level concept, I get that. But I'm just trying to comprehend this right here. So last bytes, okay, so last bytes is 1, and bytes per literal, right, that's 4. So we get a 3. And J is J less than 3? Well, J is 0. Oh, got ya. Okay, got ya. So this is just defining the upper bound. This is defining the, right? Because if last bytes is... Wait, hold on. So... This just feels kind of backwards to me. Because I'm thinking, like, okay, bytes per literal, and I know that last bytes can't ever be equal to this, right? So, hold on, bytes per literal, 4, okay. And last bytes modulus 4, right? So it can never be 4. It can get close to 4, but it can never hit 4. So if there's 3 bytes, that are left, then we have 4 minus 3, and we get 1. If last bytes if doesn't enter the big if on top is 0. Okay, if last bytes is 0, doesn't enter the big if on top. Oh, okay. Hold on. So you're saying that Okay, got ya. So I think that's what I missed. So if last byte, so last bytes has to be a last bytes has to exist. Okay, that makes sense. So this is no like -0. So bytes per literal. So if we have, so I'm still a little bit confused because if there are 3 last bytes, then if this is 4 minus 3, that's 1. J is less than 1. J plus plus. Yeah, it seems kind of like inverted to me. In this case, it can only be 1, 2, or 3. Yeah. Yep. So last bytes, right? So last bytes here. Last bytes can only be 1, 2, or 3. Got that. Bytes per literal. That's 4, right? Let me move this over for a second. So so maybe if I write this down, maybe something will make sense for a second. But I'll show you kind of what I'm thinking here. So let's do a new thing here, and that wrap kind of okay. So right here, bytes per literal, etc. Right. So bytes per literal is 4, right? So 4 minus 1, that's 3, right? So 4 minus 1, 4 minus 2 is 2, and 4 minus 3 is 1. So 3, 2, and 1, right? That's what I'm expecting. So let's just take this code for a second. And, so, instead of calling it bytes per literal, why don't we just say, 1 or 2 or 3. No, that's just gonna confuse me. So my confusion is that, okay, so yeah, my confusion here is that bytes per literal, 4. Okay, we have 1 byte left, but we're going to loop through 3 times. But we only have 1 byte left. Okay, we have 4 bytes per literal. Well, this is just going to work because it balances out, right? The middle one is just going to work. But then this one, 4 bytes per literal. We have 3 bytes left, but we're going to loop through 1 time, right? Maybe I'm reading this wrong, but that's kind of like what I'm seeing. Oh, to finish. Oh, wait. To finish the 32-bit literal. Oh. Oh, okay. So it's okay. To finish the 30. Okay. Otherwise you have. So it's. Otherwise you have 0. Okay, so hold on. Let me copy this. Okay. So to finish otherwise you have 0x 1, 2, 3, 4, 5, 6, 7, 8. Okay. It's incomplete. It shouldn't be. Okay, so we're taking. Okay, so what we're saying is we're taking what's missing. We're taking what hasn't been. Okay, let me take that for a second. Okay, so we have this. Okay, so so this is our 4 here. Right, that's our 4. Right, got 4 of these. And one of them is filled out. 4 minus 1 equals 3 null bytes. Okay, got it. Yeah, got it. So we want to know how many bytes have not actually been filled out yet. So, okay. Got it. Okay, yes, okay. Got it. Okay. Okay. So, when we're going through here, we just want the bytes that are missing, and that's why it's this way. Okay. So, and they're, yeah, okay, got it, right? Yes, right? Because they're the null, yep, because they're, got it, yeah, yep, there we go. There's the, maybe I would have understood quicker if I just, instead of just getting stuck here, I think if maybe I just kind of looked at this, like, maybe I would have made it a little bit further. Because I can see this, and I can see, yeah, okay, we have this here, and that's, right, not there, right? It's the padding, right? Because we have to get it out to that. Yeah, okay. I got ya. Okay. Understood. Then, same old, just fulfilling the contract of the diagram up here at the top. Or not this thing right here. And so here, null terminator, because right, we're gonna print this off to a file, and then some crazy formatting here. So this is for a pointer. This is a pointer specifier. Yeah, maybe. But you know, comments can definitely slow you down, though, right? Because that was to check buffer overrun. Oh, okay, that's our printing a pointer. So printing a pointer. Okay, we got 2 pointers, and any other format specifiers? Nope. And then we got hex, and then we have out plus length minus 1. So hex and out are... So we're trying to make sure that hex does not exceed... I assume we're trying to make sure that, because hex is the thing we're incrementing here. So we want to make sure that we're not exceeding output plus length plus 1, length minus 1. Got ya. So output, and we want to get the last index here, right? We want to get the last index of this. So last index of out is going to be length. We're going to add length, and then minus 1. Hold on. Dereferencing like this kind of confused. I don't dereference like this very often. They have to be equal. Okay, got ya. Guys, so they have to be exactly equal. So all your math is completely aligned where, okay, got ya. Okay, understood. So all your math is spot on, and like my math is pretty dirty, I think, where it's like I said, I think I allocated a little bit more, and so I don't think I could be able to do this because I allocated like a little bit more, and therefore, if hex is more or less fucked up. Okay, got it. So it's just that everything's the math has to work out just right, otherwise trouble. Okay, so we got some data. Okay, cool. So we got a little data set to test on, and first things first is just to test on, before we get complicated, we just want to test on just like a few things, make sure that that is working. Now this data is, is that a VLA? I forgot, like, I know, like, I try not to make VLAs, but it's like, I know you can, like, accidentally make them in C99 code. So I'm looking at this and I don't see a number here. Okay, data length, size of data. Char pointer out, the output, yeah, I don't mess with VLAs either, but I'm always really paranoid. So I'm always really paranoid that I'm gonna accidentally make them, right? Like, accidentally allocate something on the stack I did not mean to allocate. Or, yeah, that's how it works. Or wait, yeah. No, our VLAs scope local, but heap allocated. I don't know how it works. I don't mess with them either. I try to stay away from them. But I know that, like, there can be ways where you can accidentally create a VLA. So, like, I always like to put a number in here, because it's like I don't ever want to accidentally make a variable length array. So I always put a number in there because I'm like, it's implementation defined. Okay. So one more reason not to do VLAs is if it's implementation defined. Oh, you mean if it's on the stack or the heap? Okay, got it. Size of data, data length. Okay. Char pointer. Out is null. Okay. And out length is 0. So same thing that I did, right? We're going to set these to the zero state because they're the output parameters. Nice. output parameters at the end. And we got our data length. And we're going to do the hex dump. And then we do puts out. And I'm not very familiar with puts, but I know you said that my code was a very convoluted way to write a puts. So I should probably look at that a little bit more. And then free out. Okay, yeah. Okay, got it. Makes sense. Okay, cool. So one more thing we could do before we're out of here. Let's compile this. I maintain the same prototype just to be equal. Okay, I got ya. Just so that it's right, same interface. I would return the out pointer. Okay. Yeah. So let's copy this. Copy this, and let's close that. That's already good. We got too many things open. Which one of these things should I close? Let's close this for a second. I got that on the clipboard. It's on the clipboard. It's safe for now. And let's just put it in. We can always find this later. We can find that later if we lose it. Oh, this was the thing. Let's just put that over here. Let's we can find this stuff later if we need it. Let's just go paste this before we lose it. And then let's take this. Let's go into our auto hotkey folder. Let's put this somewhere. Auto hotkey folder. Go into shortcuts, SC files, and CXX. As in, I don't care what spec it is. Well, technically, it's not C89. Well, actually, I don't know. I maybe didn't take a close enough look. Yours might actually compile at C99. Okay, let's just do demo. Let's just new folder, and let's just do RBS, and then let's just do let's just say PHEXDUM dot. I'm gonna do it as C11. We're gonna make a hackish HKMF C11 mini. I think that should work. Hackish little script to get this running. Call it PHEXDUM. We will compile with all this strictness going on. And once we've compiled, we'll run it, and then it will immediately exit. And so we'll call this PHEXDUMP.sh. And then we'll open this up. Oh, wrong thing. Okay. And let's just click it, see what happens. Did I miss anything? I don't think I missed anything. Just cut, paste. See what we got. Oh yeah, my bad. So I actually need to add some things that are missing, right? I gotta add, include malloc. stdlib. Okay. Okay, let's give that another shot. So malloc is in there now. Okay, yeah. So let's see what we got here. So my machine is 64-bit, Windows 10. So we got something going on here. So let's do git bash here, so that we can kind of keep this open. And then let's put this over here on this side for a second. And then let's just do /PHEXDUMP.sh. Okay, so 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. So that's where we're getting 1, 2, 3, 4, some zeros. Okay. Oh, wait. Hold on. We got just 1, 2, 3, 4. We just got 1, 2, 3, 4. And then everything else after that is not, well, no, this would just be 2 things. And you are using, I never do this. I never trust, so, I don't understand pointer decay, so I stay away. So I don't really understand pointer decay. I know it's a thing, and I just interpret it as I can't trust pointers to tell me what their length is, so I'm like, stay away. I just kind of like stay away from it, because... But I see what... But I do see what you're doing here. Okay. And we got the 1, 2, and 3, and then what's this nonsense here? Where's that coming from? Is that... Yeah, I never do that if it's not a toy program. Yeah, I got you. Yeah, because it scares me. Where are we getting these B88 whatever's the hex? Well, here, I'm gonna take this. I just wanna... Let's see what happens if we look at more of this stuff. Just might as well play around with that. So let's zoom in here a bit. We got space. Okay, 1, 2, 3, 4, 5, 6, 7, 8. It's the debug print. Oh, in the end of function. Got ya. So there is, oh, it's this... Okay, that's what you... Oh, yeah, because you were saying these had to be exactly equal. I got ya. Yeah, yeah. I'm, like, looking at this and I'm like, I don't... Values don't mean good job. Okay. Okay, yeah, so 1, 2, 3, 4, 5, 6, 7, 8. Got it. Got it. Okay. And, still, Yep, I remember, yep, because they have to be equal, yeah. Got it. So, let's just keep on doing this. Going through this. And... Oh, wait, did I... Yep, two the same, okay. And then some leftovers, right? So we're going to test with some leftovers. So we have, and I guess we have repeatability. I'm guessing that's what this is, in case we've somehow the loop does not run the same twice through. I'm guessing that's why you have this twice. Obviously this for having just the leftovers. Is this the same again? It's the same again, except this one is different, so I would assume that is, just make sure it's not repeating the same thing over again twice for some reason. I'm not sure exactly why, but I see why that would be... Oh, wait, hold on, what did I do? This thing right here needs a... I got it. Okay. Okay, 7, 8. And... Hold on. Oh, wait, yeah, I see. That's gonna... Everything's shifted if I do that. Nah, just try different values, type different values, copy, paste. Okay, fine, sure. Okay. So, what else can we do? I don't know, I think that's pretty cool. You know what we could do? We could try this. We could try... Oh, no, that would be weird if we put uint 32s there. We could try that. We could do this. We could do this. What if we do this? Let's 0x 1 2 3 4 5 6 7 8. 0x 1 2 3 4 5 6 7 8. And then data, size of data, size t, data. I don't think it might let me do this. I don't know. Let's see if it lets me do this without anything. Nope. So I'm gonna say let me do it anyways. Uint 8 type, right? Uint 8 type cast. And it's a uint 8 pointer type. Okay, interesting. So endianness. So I'm on a little endian machine, right? So little endian, not network byte order, the stupidness. And obviously this is just terrible, but I just wanted to see what would happen. So 1 2 3 4 5 6 7 8. Okay, cool. And let's just change this back to let's not keep this. This is in my code base, so let's actually not keep this broken. So let's put that back. Okay, cool. Alright, cool. Yeah, I tested the same one unfinished literal, one full literal, two literals, 2.5. Okay, cool, yeah. So very cool, but holy crap, do I take a long time to write code. But the thing is, you know, I have a lot of comments in my code. I am trying to just go slow and steady and just have tests and have a solid foundation. But yeah, man, the amount of extra time it takes to like do what I'm doing by just being so meticulous. So I definitely could. I think I could definitely benefit from, say, a very terse algorithm like the string comparison you were showing me. Terse algorithm and just like a big block explanation of what the heck is going on is probably a good way to go in the future, when I learn things, like learn little algorithms like that. But yeah, it is 4:08, so I've been going for what, roughly 16, 17, 18 hours now. So yeah, I think it's about time to like, I'm still wired from coffee, but my brain is kind of fried. It's like I don't feel quite like going to sleep yet, but I definitely don't feel like working. So, yeah. Okay. Yeah, but yeah, that was fun. So, hopefully I will not be still working on this by next week. Like, next Monday, I'm gonna hope that I'm not still working on this, because it's just supposed to be a utility, right? To get the, get my stuff working. But let me close this. Cancel. Enter. Control C. Or not, exit. This is my terminal. So let me just go in here for a second and clear. Git status. Git add dots. Git commit -am. And PNG to works. Okay. Git push, GitHub. And also, this is up on if we do a git remote really quick. Hold on. Let me zoom in here. So git remote, this is actually on the Kanji Coder thing. So so you can actually take a look at that on Kanji Coder, the Kanji Coder GitHub. It's up there. But yeah, so I'm gonna keep on working on that for the rest of the week, hopefully. I mean, I say hopefully, but you know, hopefully not, but realistically, with how long that took, I think so, unless I can just be a little bit faster with, right? Because I made all that boilerplate to like make the rig for reading the arguments and routing to the correct functions and all that stuff. So I'm hoping that the next functions that I write are not so long. I'm hoping, right? I'll probably do something really hackish. So like when I want to parse something like when I want to parse, like, you know, int32, sorry, like if I want to parse this, u32, some 45. Oh wait, we're not supposed to. We get banned if we use the number 45, right? That's like a thing now, right? 40. And right, so if I write something like this, and then we have some, like, you know, we have some numbers, right? So 0x, whatever the heck. Obviously not hex, but right, if we have something like this, right? Then if I want to extract this naked array from here, yes, I have heard that from you, which I can't say anything on the stream. But anyways, I am a fan of South Park, um, but yeah, if we do something like this, what we could do is we could just check for, we don't need a full lexer, right? We're not going to write a full lexer for this. We're just going to be like, hey, there's this thing, and hey, there's this thing, right? We're just going to look for that open and closing thing, and, you know, if we have comments, well, if we have comments, then we're going to crash. If we have comments, we're going to crash. And we're gonna kind of like do a, we're gonna pretend to parse it. I mean, we're gonna parse it, but we're just gonna parse it. We're not gonna make a complicated parser. We're just gonna be like, hey, look for this brace, look for this brace, you're done, right? I think that would be the easiest way, because then we just get this brace, we get this brace, and only plus plus to get what's after here. Yeah, exactly. And I've written a lot of parsers, because this thing called, I'm not a fan of regex. I learned some regex, but then it always I always forget it. So a lot of times, where other people would use regexes, I would use like nested loops and helper functions and things for whatever I want to do. I mean, sometimes it's good. Sometimes it's good when you want to whip up something really quick, when you're trying to, like, search for something in, like, say, a gigantic shortcut file. Yeah, so I have, like, so if I find, like, so, for instance, since I forget things so much with regex, I have, like, token finder regex. Like, that should be a thing, I think, right? Token finder regex. And there you go, like, oh god, I don't know what this is, but guess what? I know that I just gotta go in here. And I just got to go in here and replace this with what I'm looking for, right? So that's just to find like a token where it's like, you know, some token here, right? And the problem here is that we don't want to find this one. Some token here, not my president something blah. Right, but we don't want to find this, right? So even though these match, we don't want to. If we do a simple Control F, right, we're gonna find this one, and we're also gonna find this one, right? So this regex is just gonna help me with that. But yeah, I wrote like a lot of crazy regexes when I was at this one job, which didn't go over very well. I was always like, yeah, it kind of sucked, but I don't know. I made them like a back-end kind of server in Java to get hired, and then I ended up getting put on JavaScript and UI stuff, and I hate UI, I'm not good at UI, and, so, you know, interviewed for one thing, and then my job was doing another thing, is kind of what happened. And so I think he said, oh, I thought you were better at HTML than you really were, and that's probably true. You know, I just stuck Bootstrap on it. Stick Bootstrap on it, throw a little jQuery, done. And I guess, yeah, so sometimes things look better than your actual coding ability, right? Like sometimes people judge appearances, even programmers, even programmers will judge appearances, outward appearances, more than the quality of the code, and, that's just a thing people do, but, I mean, I guess in the end, it's, you know, the only thing that really counts is what you can get on screen, so, I guess that kind of makes sense. Let me close that. So, I'm going to put this back over here. We're going to close this. We're going to... We got too many folders. I don't know if I made a shortcut for this folder here, so I'm going to close this, and I'm going to close this, and I'm going to make a note of this, and there were some shortcuts I wanted to make, but I'm going to figure this out, or, actually, I'm going to be lazy, so, PHEXDUM folder. I don't think I have such a shortcut. Oh, I do. PNG hex dump folder. How about that? Do I have that? How about PNG hex dumper folder? Huh? Do I have that? Nope, not that. Okay, there we go. Put that in there. Okay. All these X's were things that I was trying to find out while I was programming all this. So I'm going to be really lazy here. And I'm going to save some time, and I'm just going to say, I'm going to say full file to path to clipboard, and we're just going to say in the shortcut file here, read, so I'm lazy. I don't want to figure out making these snippets. It's like, am I going to need this snippet right away in the future? Well, I'll probably hate myself, right? This is like me telling myself to Google it, all passive aggressively, but I don't want to think about this stuff. So, you know what? Include maker. Yeah, like any of this stuff is in what we just did somewhere. Save text, C99, save ASCII version. It is actually in there, right? So we have that, so it's in there. Save file to disk, somewhere in there. This other thing, yeah, it's in there somewhere. So, yeah, it's in there somewhere. Also, we're not going to even include where the, we could at least indent this and make a little commentary. You know, make a little commentary so we know, have a little bit more information to go on, because maybe this isn't enough. And just, C hex dump folder, right? So, that is not what I was expecting. I thought hex dump folder was already a shortcut. Oh, it kind of interlaced. So my shortcuts did a very bad thing. It interlaced two things together. Let's try that again. Hex dump folder. Hopefully that's not a... interesting. Am I out of RAM? Oh, no. Or hex dump... Well, I don't have a thing called hex dump folder. Is that what's going on? Is there no shortcut called this? Is that what's going on? Oh, I guess not. Okay. Hex dump folder, I guess. And we'll put that commentary there, and we'll just hope that's good enough. We could also kind of like surround this like this, box it up. You might regret this later. Okay, good. Okay, we're done. We're done. I'm just out of here. We're out of here. It's over. It's over. I don't know what I'm gonna do. Maybe I'm gonna get some food. I don't know what I'm gonna do. But good night. Good luck with your 6,000 lines of code? Yeah, yeah, so. Yeah, alright. So, same deal, like, I kind of don't stream at a very consistent schedule, except for Monday. Monday, I'm pretty consistent, because I just, you know, get high on coffee and just crank it out. But every other day, totally inconsistent, and I never do work on Sunday. So, I'll see you around, and I'm going to stop the stream now. Oh, actually, no, I'm going to do this first. Okay, this is 54, and we're going to continue hex dumping later. Okay, now I'm stopping the stream.